relations and functions. I kind of feel like we've already defined these in a previous module, but just to make sure we have a relation is any set of ordered pairs. Okay. So this, most of the time, the thing that we think of is like X and Y because we deal with the graphing of the different ones. But this could be even, like if we're doing test scores, I could put your last name and then your test score. So it doesn't necessarily have to be numbers. It could be anything like that. A function is any relation where for every, I don't know if where for is the correct way to say that, but where every X has exactly one Y. Okay. So if I ask you what your X goes with, you have one answer. So that like even the last name and test score, that would be a function because if I ask you, what last name, Smith has a 76. But if I let that person, if you got to retake a test, if you got to take the test 2 attempts, that would not be a function because if I asked Smith what he got a 76 the first time and an 82 the second time, okay? So for every X, there is exactly one Y. And then we have the domain is really the first element, which for us is usually an X because we usually deal with X and Y. And the range is the second element. And I say element because it could be, like I said, it could be X and Y, or it could be last name test score. So if the domain would be all the last names and the range would be all the test scores. But usually our domain is our X's and our range is our Y. I think that I want to... Oh, that's not the one I was looking for. I wanted to... Oh, this one. We're doing this one. Okay, clicked on the wrong one. Yeah, this is... I want this picture. I know it looked quite a bit different on Alex than it did. Okay, so we're trying to decide if these are a function or not. So it gives us a bunch of different ranges. So for every X, there's exactly one Y. So if I look at this one, if I ask you what B goes with, you would say 5 and -9. So this is not a function. For everything in the domain, they can only go with one thing in the range. So really you're looking, there'd only be like one arrow coming out of each thing if it's a function. On this one's definitely not a function because if I ask you what R goes with all of those. And so on the next one, T, if I ask you what T goes with, you would say chair. K goes with chair. M goes with chair. R goes with chair. J goes with chair. I know they all go with chair, but this would be a function because it's for every X, there's exactly one Y. It doesn't matter that they all go to the same thing. If I were to draw this out with arrows, it would be, sometimes that's nice to do, T, K, M, J, R. They all go to chair, but there's only one arrow coming out of each of those, okay? So this is a function because if I ask you what any of these go with, you only have one answer. On this one, -3 goes with 6, but then -3 also goes with 8. So that's kind of what you're looking for is repeats in the domain that go to different numbers. This would not be a function, okay? So for every X, it can only go with one Y. See, they changed that on me, so I got to pay attention. Okay. Vertical line test this is a way to look at a graph and see if it is a function. Oh, they changed this problem on me. Now I got to have like 5 different pictures. Yeah, Alex updated this problem. Okay, so to do the vertical line test, the rule is, do you want to, or if you draw a vertical line anywhere on the graph, and it goes through it more than once, it is not a function. Okay, so if I draw a vertical line right here, it hits it twice, so it is not a function. So a vertical line test is technically if you draw a vertical line anywhere on the graph and it only goes through it one time, then it is a function. So I kind of like to think about it the opposite. If it hits it more than once, it is not a function. Okay, I probably won't draw all these. Even one like this is fine because no, undo. If you have a bunch of points like this, and I start drawing vertical lines, I never hit more than one point. So it only hits it in one spot. So that's fine. The vertical line test is kind of the easiest one, just because you're just trying to see if you draw a vertical line anywhere on there and it does not, and it hits it more than once. Man, I gotta do this one too. This one right here will end up being a function because when I draw a vertical line right here, it hits it here, but it does not hit it here because that is open. Okay, so same thing on this side. It does hit it here, but it doesn't hit it there. So yes, this is a function. That one would be a function. You can draw a vertical line anywhere on it and only hit it once. This one would not be a function, right? If I drew a vertical line, it would hit it twice. And this one would not be a function because if I drew a vertical line over here on the left, it hit all three of those. So you just draw a vertical line, and if it hits it more than once, it is not a function. All right, evaluating a rational function. Let me write this out. F of x equals 2x plus 1 divided by x minus 3 at x equals 4. Okay, on this one, when it says evaluating, all you're doing is plugging it in. Okay, whatever's inside the parentheses equals x, so I just plug a 4 in anywhere there's an x. So that would be 9 over 1, which would be 9. So this says the point, this is an xy, so the point 4, 9 is on my graph. These all mean the same thing. This is my x. X equals 4, y equals 9. So function is just a different way to write stuff. But I input a 4 and I get out a 9. So my x is 4, my y is 9. Whatever my rule or next topic, but this is whatever is inside the parentheses, you need to plug in for your x. So this one says f of a plus 2. So I'm going to take all of this a plus 2 and put it in for my x. So I do f of a plus 2. I take a plus 2 and put it in for my x. And then I simplify as much as I can. So distribute the 3. 3a plus 6 minus 5 would be 3a plus 1. So when I inputted an a plus 2, I got out a 3a plus 1. Okay, I was trying to think about like manufacturing. If you manufacture A products a day and you want to try to increase it by 2, how does that change my cost or my profit or anything like that? That's kind of the idea behind something like that. But whatever's inside the parentheses, you always plug it in for your x. See, this is a new thing. The domain of a rational function. Domain of a rational function, it says excluded values. Okay, so this is easy to start. The domain of a rational function, the domain is all the numbers that x can be. All the numbers that, it's the first, right? We said it deals with our x's. So it's all the numbers that x can be. Well, if we start thinking, well, 5 would work, and 6 would work, and -2 would work, and -8 would work. So what's easier here is find what x can't be, okay? And then say everything else. Then say everything besides that. All right, so in a fraction, you can either divide by 0. So when you have a rational one, what you're trying to do is figure out what number makes the denominator go to 0, okay? So x minus 4 equals 0. If I solve this, I add 4 to both sides. So this is the one number that x can't be. If I plug in a 4, I'd get a 0 in the denominator, and I cannot divide by 0. So you set the denominator equal to 0. So what you want to do on these is set the denominator equal to 0. I was looking at the topics because there is something that makes this a little bit harder. I may do it on the next one just to like show you. I don't think you have to do it on these because I don't like, they're just kind of hard, so I try to take them out when I can. But I probably need to at least show it to you. So on this one, again, the same thing. You want to set the denominator equal to 0. So I do x squared minus 9 equals 0. You can actually solve this 2 different ways. Probably the first thing that comes to your mind should be some kind of factoring. So x times x is x squared. 3 times 3 is 9, a plus and a minus. I'll show you the other way in just a second. And then you set both of these equal to 0. So on this one, I subtract 3. This one, I add 3. So those are the two numbers that x can't be. If I plugged in a -3 or a 3, I'd get a 0 in the denominator, which would be bad. You could also do it this way. You could do the square root. The square root of 9 is 3, but when you do the square root, you put plus or minus. I prefer to do it this way, but I know most of y'all think factoring difference of squares, which is fine. All right, so the one thing that may pop up on here is those are the two numbers that x can't be. If I plug in those numbers, I would get a 0 in the denominator, and you can't divide by 0. So it can't be -3 or 3. So this is telling us what it can't be. The domain is technically whatever it can be. So if it can't be -3 and 3, it could be anything less than -3, which would be -3 to -infinity. It could be anything between -3 and 3, or it could be anything greater than 3, which would be 3 to infinity. So sometimes they make you write it in interval notation. I try to take this topic out when I can, but if it ever makes you do it, that's that's the technical correct answer, because this is the numbers that x can't be. It can't be -3 and 3, so it could be anything less than -3. It could be between -3 and 3. Or it could be anything greater than 3. Hopefully you don't have to do that too much, because that is a pain. But if you do have to do it, it is nice just to draw out the number line and say, okay, x can't be -3 and 3. Like it can't be -3 and it can't be 3. So it could be anything less than -3. It could be anything between -3 and 3. And it could be anything greater than 3. All right, so with rational functions, you set the denominator equal to 0 because you can never divide by 0. With the square root, what number can you not have under the square root? Negative, right? Can you do 0? Yeah, the square root of 0 is 0 because 0 times 0 is 0. So what you do on this one to figure out what numbers it can be is you would say, you would set, they call it the radicand, under the what's under the radical, to greater than or equal to 0. I always need this to be a positive number or 0. Okay. So you set whatever's underneath the radical greater than or equal to 0. So then you add 3 to both sides. X has to be a number bigger than 3. So 3 to infinity. That's the interval notation. I think you'll probably have to write this one in interval notation. This one's easier to do in interval notation, though. On this one, g of x equals the square root of 2x plus 5. So again, you are going to set what underneath the radical to greater than or equal to 0. You subtract 5 from both sides and divide by 2. It's okay that you get a fraction. I need any number bigger than negative 5 halves. You would do a bracket because it is greater than or equal to, and you do infinity because you want any number bigger than greater than negative 5 halves. All right, symmetry. So symmetry means that you can like fold it and it matches up. Okay, I didn't change this one on me. The X and Y, there's 3 different types of symmetry. There is the X-axis symmetry, the Y-axis symmetry, and the origin. The origin is the hard one. Probably should even check my answer because it confuses me a little bit. But X-axis symmetry would be if I can fold it across the X-axis and it matches up. So if I fold that one up, that would be no, right? Y-axis symmetry would be if I can fold it across the Y-axis and it would match up. That one would be yes. Okay, so if I fold that from left to right, if I fold it vertically, you can see that that would match up. If I take this and put it over here, it would match this over here. The origin, I think the easiest way to do that would probably be if you can fold it across like a diagonal line and it matches up. Okay, so like I'm going to go ahead and skip to the origin on this one. Like if I fold this across this line, that one would match up. If I fold this one this way, it does not match up. And if I fold it left and right, it does not match up either. Okay, on this one, if I fold this one, I don't know, hot dog style or whatever, hamburger style. I guess it'd be hamburger style on this one. Fold it up and down. That one would match up, so that one is good. If I fold it, this one would be hot dog style, like vertically, left and right. That one matches up as well. And I believe it will match up this way too, right? If I folded that across the green line, it would match up and get the origin. So the X and the Y, folding it up or down or left and right is pretty easy to see, but that origin one is a little tricky. So be careful on that. But that's just checking symmetry. And the reason you check symmetry is because it does start to tell us different things about the graph, which we will get into. Okay, the difference quotient. The difference quotient is, it kind of leads you into something in calculus, but I might be able to show you a shortcut. I might not on this. We'll see. So the difference quotient is this f of x plus h minus f of x over h. It has to do with like limits and derivatives and things like that when you get into calculus, but we start to show you the introduction to it in college algebra. What you have to do is find each of those. So if I find f of x plus h, that would be like plugging a x plus h into x plus h into the x's. So 2 times x plus h plus 3 Distribute the 2, it'd be 2x plus 2h plus 3. So when I plug in an x plus h, I get out 2x plus 2h plus 3. I believe that's all we have to find right there. So now if I plug it into this big formula right here, I do f of x plus h, which is all of this, right? That's that. Minus f of x, well, that's just the original, divided by h. And it becomes a big simplification problem. The easiest way to subtract polynomials is there's like a -1 out in front. So if I just change this to -2x and -3, it makes it super easy to combine like terms. But look, 2x minus 2x, then I have 2h. 3 minus 3, so everything cancels out besides 2h. 2h over h. Well, those cancel out, and I just get 2 for my answer. And it always does simplify down like that. A lot is going to cancel out. Let's do this next one real quick and see what it cancels out. This one's a little bit harder. I don't even say a little bit harder. It's just a little bit longer. I don't like using G on this one. I'm switching it to X. Or F, I mean. Doesn't really matter, but so we're again going to plug it into this one. So what you have to do is find that f of x plus h. So f of x plus h. So I do x plus h squared minus 4 times x plus h. So these are where these get a pain because you got to simplify a bunch, but you have to FOIL this. When you FOIL it, you get x squared plus 2hx plus x squared. I'm skipping a step there because I know y'all know how to FOIL, right? Distribute the 4, so -4x minus 4h. And I cannot simplify that anymore. So now I go plug it into my formula. My f of x plus h is x squared plus 2hx plus x squared minus 4x minus 4h minus x squared minus 4x all over h. Yes?
Is that second x squared supposed to be h squared? Or is it just x squared?
It is supposed to be h squared. That one right there is supposed to be h squared. Thank you. I realized that when I went to simplify here in just a second. All right, so I would do the same thing. I'd make this -x squared plus 4x. Just change the signs in there, and it makes it easier to simplify. So now if I look, x squared minus x squared, 2hx, I don't have anywhere to put. H squared, -4x plus 4x, and then minus 4h. So when you get done simplifying here, there should only be like stuff with h's left. I think that's the way it'll always work out. So now all 4 of those have an h in it. So if I divide an h out of all 3 of those, I'd have 2x plus h minus 4. And that would be my answer. Do y'all want to learn calculus real quick? No? Yes? The shortcut way of doing this, a derivative, what a derivative is, or the way, I'm not going to go into what a derivative is. The way you do a derivative is you take the exponent, you drop it down out in front, and then you subtract it by 1. So this exponent is 1. So 1 times -4 would be -4. When I subtract it out, I have x to the 0. So this is just 2x minus 4. An easier way to see a derivative is like 5x to the 7th. So 7 times 5 would be 35, and you subtract it by 1. That is how you do a derivative. Okay, I'm not going to go into too much like more about derivatives, but if you notice, 2x minus 4, 2x minus 4, right? That plus h, I'll go up to this one real quick. Let's do this one real quick. The derivative of this one, 2x plus 3. Again, you have a 1 right here. You drop it down, so 1 times 2 is 2. That becomes x to the 0. The rule on this is it goes away, but technically x times 0, 0 times 3 is 0. So that becomes 0. So this just becomes 2. That's kind of like the shortcut way of doing these. The reason you put plus h, again, if you don't understand derivatives, that's fine. Like, it's just a shortcut way. But like, you have 2x minus 4 right here, and you have 2x plus h minus 4 here, so your only thing you're missing is a plus h. Technically, when you do this right here, they say like lose something, so that's what the plus h is. So if you ever have anything higher than a problem with x squared in it, you'd always put a plus h in there. X squared or higher. Again, just an alternate option. You can try to shortcut some of those if you want to, but let me go get the actual word problem on this one. So you have one word problem. Oh, is this all you have to do on these? Okay. This one is actually easier than what I have even. A fuel tank of a certain airplane can hold up to 300 gallons of fuel. Let W be the total weight of the airplane. Let F be the total amount of fuel in tank. And suppose that you have this formula W equals 6F plus 4,000 gives F as a function of, give W as a function of F. So identify the correct one. The easy way to probably do this is to say whatever this is going to be my domain. And then whatever you're trying to find is going to be my range. So F is my total amount of fuel. My range is my weight. And then it says to find the set of values that would work. So we know it can hold up to 300. So that's where they get the 0 and 300. You can't have negative fuel. So a lot of times when you're dealing with real life, you're going to have constraints like that. Really, I'm that close to the edge. Can't have negative fuel. And then the set of real numbers for the range, we might need to work out real quick. If F equals 0, then it's 4,000. That's the smallest number it could be. The biggest number, it can only hold 300 gallons of fuel, so it would be 300. So when we plug in a 300, what is that, 1,800? So that's 5,800. So I know since the fuel is limited to 0 to 300, my weight is going to be between 4,000 and 5,800 because I have a set number of my fuel tank. So I'm going to have I can plug those in and figure out what my minimum and maximum weight would be.